Yep. So I'm Palo Arias. I'm originally from Colombia. This is my second year master as a master student with Dr. Singh. So we are, well, we don't have the plots here. They are all the way there in that corner. So I think because the time and the logistics, it's very hard to go all the way there. But if someone wanna go and walk there, just let me know. Uh, so we are evaluating A varieties that we have worked with Eric. So Eric have recommended us A varieties, very droopy, and so it's A variety 4 very droopy and 4 very erect. So we are calculating the differences of these two canopy types under two seeding rates, 0.8 and 1.6 across two planting times. So we have optimal planting time that is around mid-September and late planting that is mid-October or end of October. So we have interacting these canopy types with these two seed crop management practices to see what is the differences in canopy architecture. So we are calculating tiller angle, we are calculating leaf angle for both canopy types, we are calculating light interception using SunScan, and we collect biomass samples to evaluate the radiation use efficiency differences between these two canopy types. So we have seen droopy varieties having better light interception compared to erectophile varieties. But however, the erectophile varieties have better radiation use efficiency compared to the droopy ones. This radiation use efficiency is basically the way that they convert the biomass per unit, per light unit. So what other calculation that we have seen is canopy closure too. So we calculate canopy cover. So the difference between droopy and erect is that the droopy ones close faster the canopy compared to the erect varieties. So part of the results that we have seen so far is that the differences in yield between erect and droopy is they don't have significant differences in early planting. But for late planting, the droopy varieties have shown better yield compared to the erect varieties. So that is one of the main results that we have seen so far. Regarding the seeding rate, we haven't seen any significant difference in seeding rate between these two canopy types. But that is one of the interactions that we have seen between planting date and canopy type interaction. That the droopy ones, as you plant late, are gonna compensate that loss on yield for delayed planting. So that is what we have so far, and yeah, thank you.
I have a question for you.
Yep.
So you said that when planting late, the droopy varieties have higher yield.
Yes, correct.
When planting early, you said there's no difference at all between the varieties?
When planting earlier, we haven't seen a yield differences between both canopy types. Yeah.
Okay.
But the droopy ones are yielding more than erect in those late planting.
Okay.
Yeah.
So there wasn't a significant difference between them at the early planting date?
Between two, no, there was no significant differences.
Okay.
I would assume that'd be correlated to soil temperature or more photosynthesis happening, but
Yeah, so what we is happening is that the droopy varieties, because they close faster, the canopy closure is faster, so they have better light interception, right? So for those early planting days, the erect varieties had better radiation use efficiency. That means that they convert the light better in biomass. So they are having, or they are competing with the droopy ones in early plantings in the same way. But for late planting, they have a disadvantage. The red varieties have a disadvantage in late plantings because the droopy ones, light interception is higher compared to the red ones.
But how late is late in that trial? You might have said it, but I don't.
How late is
How
what?
late is your late planting in that?
So the late is mid-October, between mid of end of October.
Okay, so
What we have
moderately
seen
late.
so
Moderate,
far
yeah.
with these erect and droopy canopy types is that usually erectopile canopy types, they are more suitable for high yield potential management basically. So
Rec ones,
yeah,
you
they're
said?
rec ones. So
Yeah.
if you plant early, they have this better conversion in light into biomass, right? So they have the potential of achieving better yields. But when you go to non-ideal conditions, you plant late or you don't manage them very well, like in terms of fertility or a soil type, basically, they kind of not, they cannot reach the droopy canopy files, canopy architectures, basically. In this case, the droopy ones, that they have this better interception of light, they can capture more of this light initially. They are better for this type of conditions, basically, what we have seen so far working with these canopy architectures.
And the row spacing was
The row spacing similarly.
7.5 or?
Yeah, 7.
The 7.5, yeah.
So with what the two of you know, with the work that you've done, if you were to try to take the information you've learned, how would you build a high management or a high yield scenario? What would be the ingredients that you would put in terms of row spacing, seeding rate, erectophile versus planophile?
Well, the erect varieties will behave better in high seeding rates, first of all, and early planting. Well, that is another option, right? Like the most of the varieties are droopy, right? But we are not saying that the red is a better choice. That droopy one is that another option, right?
Yeah.
So yeah, the red ones were early planting is obviously the best crop management. So planting earlier is going to be always better. But if you go late, would the recommendation is use droopy in low seeding rate. That could be in low seeding rate. We are trying to analyze the seeding rate treatment, but we haven't seen in the first 2 years any difference in seeding rate. So the only interaction that we see significantly different was the planting date and canopy type interaction.
And I've been studying these erectophile canopy types in different seeding rates. So we have one erect variety that's our most erect variety. Usually it's Wharf, MCIA Wharf. And we have 4 seeding rates going from 0.8 to 1.6, 0.4, 0.8, 1.2, and 1.6. And we are planting 7.5 using a drill, and we are planting 5 inches using the precision planter. And what we have seen so far is the combination of narrow rows and precision planter allow us to reduce the seeding rate. So the optimum seeding rate that we have seen so far in my first year results were around 1.01 million seeds per acre using a precision planter at 5 inches, right? But for the drill one, it was greater than 1.6. So if you use a system that's not going to be precise, you probably need to compensate these erectophile canopy types with higher seeding rates.
And that was an earlier late planting?
That was an early ideal planting, optimal planting date. We didn't play with these two planting methods on different planting dates yet. But yeah, my trials so far are planted in optimal.
That could be the next step.
Yeah, that's the next step. And also, we are looking to see if where this difference is coming from. It's coming from erectophile versus planophile varieties, or it's coming from a precision planting equipment or versus drill, you know. or narrow rows. It's coming from precision or narrow rows, basically. We don't know yet because we don't have a drill to compare yet in narrow rows, right? So that's gonna be our next step to compare these two equipments in narrow rows, basically.
It sounds like you're gonna soon, right?
That's the plan.
Yeah.
Yep. So I think that's it.
Anybody have any questions?
Thank you.
Yeah.
Thank you, everyone.